Evolution of Earth in 8 minutes. The story of our planet begins approximately 46 billion years ago, when the Earth was formed from the dust and gas surrounding our young sun. This process, known as accretion, involved particles clumping together under the force of gravity to form larger and larger bodies, eventually creating the Earth. The early Earth was a hot, molten mass, with temperatures so high that its entire outer layer may have been liquid. This intense heat was generated by the impacts of numerous celestial bodies colliding with the young Earth, contributing to its formation and growth. As the planet cooled, heavier elements like iron sank to the center, forming Earth's core, while lighter elements like silicon and oxygen rose to the surface to form the crust. This differentiation of materials set the stage for the development of the complex, dynamic planet we know today. The cooling process allowed the formation of a solid crust, which has since been continuously reshaped by geological processes. The Hadean Eon, lasting from Earth's formation to about 4 billion years ago, was characterized by extreme conditions. The planet was bombarded by meteorites, and volcanic activity was rampant. No rocks from this time period have survived, but we gain insights from the study of lunar rocks and meteorites. During this eon, the first primitive crust began to form, and Earth's atmosphere started to develop from volcanic outgassing, although it was very different from the air we breathe today, lacking free oxygen. Moving into the Archean Eon, from 4 billion to 25 billion years ago, life began to make its first appearance. The earliest known fossils, dating back over 3 billion years, are of simple, single-celled organisms called prokaryotes, including bacteria and cyanobacteria. These organisms were incredibly resilient, thriving in harsh environments like hydrothermal vents and shallow, warm seas. Stromatolites, layered structures formed by the activity of cyanobacteria, are among the oldest evidence of life, dating back to this eon. Photosynthesis by cyanobacteria began to release oxygen into the atmosphere, gradually transforming it from a reducing environment to an oxidizing one. This process set the stage for the evolution of more complex life forms in the following eon. The oxygen produced by these early organisms also led to the formation of banded iron formations, which are layers of iron-rich rock that provide evidence of this crucial period in Earth's history. The Proterozoic Eon, spanning from 25 billion to 541 million years ago, saw significant changes in Earth's atmosphere and biosphere. The Great Oxygenation Event, occurring around 24 billion years ago, marked a dramatic increase in atmospheric oxygen levels, leading to the first mass extinction of anaerobic organisms that could not survive in the presence of oxygen. This period also witnessed the emergence of eukaryotes, organisms with complex cells containing a nucleus and other organelles. These eukaryotes eventually gave rise to multicellular life forms, setting the stage for the incredible diversity of life that would follow. The Proterozoic Eon also saw the formation of supercontinents, large landmasses composed of multiple continents fused together. One of the most well-known supercontinents, Rodinia, formed around 13 billion years ago and began to break apart about 750 million years ago. The breakup of Rodinia had significant effects on Earth's climate, contributing to a series of glaciations known as snowball Earth events, during which the planet's surface may have been almost entirely frozen over. The transition into the Phanerozoic Eon, beginning 541 million years ago and continuing to the present, marked a new era in Earth's history, characterized by the proliferation of complex life forms. The Cambrian Explosion, occurring around the start of this eon, was a period of rapid evolutionary diversification, resulting in the appearance of most major animal phyla. This explosion of life was driven by the increased availability of oxygen and the development of predation, which spurred evolutionary adaptations. The Phanerozoic Eon is divided into 3 eras: the Paleozoic, Mesozoic, and Cenozoic. The Paleozoic Era, lasting from 541 to 252 million years ago, saw the colonization of land by plants and animals. During this time, life flourished in the oceans, and the first vertebrates appeared. The Devonian period, often called the Age of Fishes, saw the rise of diverse fish species, while the Carboniferous period led to the formation of extensive coal deposits from the remains of ancient forests. The Mesozoic Era, from 252 to 66 million years ago, is known as the Age of Reptiles, dominated by dinosaurs. This era witnessed the breakup of the supercontinent Pangaea, which had formed during the late Paleozoic, into the continents we recognize today. The Mesozoic also saw the rise of flowering plants and the first birds and mammals. The era ended with the Cretaceous-Paleogene extinction event, likely caused by an asteroid impact, which led to the extinction of the dinosaurs and paved the way for the rise of mammals. The Cenozoic Era, from 66 million years ago to the present, is often called the Age of Mammals. Following the extinction of the dinosaurs, mammals diversified and became the dominant land animals. This era has seen the development of modern ecosystems and the evolution of humans. The Cenozoic is marked by significant climatic changes, including periods of glaciation, which have shaped the Earth's landscapes and influenced the evolution of life. Throughout Earth's history, plate tectonics has played a crucial role in shaping the planet's surface. The movement of tectonic plates has caused continents to drift, collide, and break apart, leading to the formation of mountains, oceans, and other geological features. The concept of continental drift, first proposed by Alfred Wegener in the early 20th century, laid the groundwork for the modern theory of plate tectonics, which explains the dynamic nature of Earth's crust. Evidence for plate tectonics includes the matching coastlines of continents like South America and Africa, the distribution of fossils across continents, and the presence of mid-ocean ridges where new crust is formed. The theory of plate tectonics has revolutionized our understanding of Earth's geological history and continues to be a central concept in geology. In addition to tectonic activity, Earth's history has been influenced by various external factors, such as asteroid impacts and changes in solar radiation. These events have caused mass extinctions and dramatic shifts in climate, affecting the course of evolution. The most famous asteroid impact, which occurred 66 million years ago and contributed to the extinction of the dinosaurs, is just one example of how external forces can shape life on Earth. Thank you for joining us on this fascinating exploration of Earth's evolution. If you enjoyed this journey through time, be sure to like, subscribe, and hit the notification bell to stay updated with more intriguing stories and scientific explorations. This has been another exciting episode of InfoBurst, where we bring the wonders of the universe right to your screen. See you next time.